Let x be a continuous variable with PDF given here. And given x equals x, y is a uniform distribution on negative x to positive x. Find the joint PDF, find the marginal density of y, find this probability. Let's first figure out what is the conditional density of y given x. So here we know that the conditional on x equals x, y is uniform. So the density function y given x equals x must be a constant here, because the integral of a density function must be 1. So in other words, this area must be 1. So the constant here must be 1 over 2x, because 1 over 2x multiply this length here, 2x is equal to 1. So let's write down this function. The function of y given x is equal to 1 over 2x, and y is ranging from negative x to positive x, so write this as y is less than or equal to x, and this is 0 for all the otherwise is 0. So given the conditional density of y given x, we are ready to calculate this joint density here. Let's first write this joint density as xy is equal to f y given x. So the joint density of x and y can be written as the conditional density of y given x multiply the marginal density of x. So this is equal to, so the first function we just calculated, the conditional density, is 1 over 2x when y absolute value is less than or equal to x. And fx here is given here, fx equals 2x. When we multiply these two functions, this one and this one, multiply them, is 2x multiply 1 over 2x, which is 1. And this is true when x and y in this range. So let's write this down. So it's x is less than or equal to 1, greater or equal to 0, and y is less than or equal to x. For all the other values of y and x, which is not in this range, it will be 0. So this is 0 otherwise. So now we have the joint density of x and y. Let's calculate the second one, the marginal density of y. First, let's figure out what's the value of y, the possible value of y. Now, y is a uniform distribution between negative x and positive x. X is between 0 and 1, so y must be less than or equal to 1. So let's calculate fy. This is equal to negative infinity to positive infinity xy dx. This is a general formula to calculate the marginal density given the joint density. So basically, given the joint density, x and y, if we want to calculate the marginal density of y, we just need to integrate out the x here, right? So now let's first figure out what's the range of x here, because we're doing the integral. So based on the joint density here, so we just calculate the joint density, and the range of value of x is greater than the absolute value of y, and x also is also between 0 and 1. So the integral must be from y absolute value to 1. So the density function is 1. So this is 1 dx. So this is 1 minus absolute value of y. And keep in mind that the value of y must be absolute value of y must be less than or equal to 1. If y is outside of this range, the density function would be 0. Let's look at C, this probability. Let's calculate this. Probability y is less than x3. So based on the question here, we know that the y is a uniform distribution. So if we condition on x, and the density is a constant given x equals x, So let's write this as probability y is less than x3. That's a conditional x equals x, fx dx. So basically, to calculate this probability, that's the first condition on x equals x. Then we integrate this x. This is also a general way of calculating this kind of probability. So you condition on x, then integrate the x. Because x is between 0 and 1, so this integral is from 0 to 1. Let's further write this down. Probability y is less than, because conditional x equals x, the x is no longer random. So right, so if you look at the original probability, the x here is random. Now we are conditional x equals x, so y is less than. Note that we use lowercase x, so x now is a number, not a random variable anymore. So conditional, because we're conditional x equals x. So fx here, we know this is 2x, so write 2x here. Okay, this is equal to probability y is less than x to the third, greater than negative x to the third, given x equals x, 2x dx. Okay, this is equal to, now we already calculated that given at x equals x, the y is a uniform distribution. It's given by this plot. This is the density function y given x equals x. And so based on the question here, based on the formula here, y is between negative x to the third and positive x third, and y is a uniform distribution. So it's the density function is here. So let's put this down. So this is negative third and positive x to the third. I know that because x is between 0 and 1, x to the third must be less than x, so must be here. So to calculate this probability, so we know that y is a uniform distribution now. It's between these 2 points. So the probability is essentially just this area. Okay. So what this is 2x cubed multiply this constant, which is 1 over 2x. So let's write this down. So it's 2x cubed times 1 over 2x times 2x dx. And this is 1 over 2. Thank you for watching.